Speaking of reliability, a podcast with good friends talking with you about reliability engineering topics.
Welcome to Speaking of Reliability. This is Kirk Gray.
And this is Fred Schenkelberg. Hey, Kirk.
Hey, Fred. It's good to hear your voice again.
Yeah, pretty good. So I understand you got a new headset. And did you get a hold of the vendor?
No. But I did have problems with the little 3.5 millimeter plug into the little adapter, and it's just kind of one of those user failures, and you don't really realize it that you've got to push it all the way into into the connector, and
you have to seat it well.
It's seated well because in a 3.5 millimeter connector with a microphone, you've got several sections, and each one you click in, and you may think you've got it all the way in, but you've got one more millimeter to go inside.
Yeah, and if you push too hard, then you shove the connector right off the circuit board, and then you got a dead plug. There's all kinds of issues there. But right. I mean, it's similar. I had a former client was looking for some help on a component they were having trouble with, and at some point he says, do you know how it's failing? What's the failure mechanism? What's happening?
Right. Fundamentals.
And he says, no, not really. We haven't sorted it out yet, and everything else. I said, you didn't send it to the vendor, did you? I said, how'd you know? It's like, don't do that. Did they give you anything useful? No. Send it to your own failure analysis lab, or get a contract with a good lab, and get some pros to tell you that, the face is chipped, or it's out of round, or it's got a loose cable, or it's delaminated, or whatever. But once you know how it fails, then go back to the vendor.
Right.
And say, hey,
and you can't, they're not going to give you the answer. And an example was, I was working for a small company that made variable voltage control oscillators, tiny little thing. Mm-hmm. And inside it was a varactor, which is a voltage ability to make using a diode, make its capacitance changed by voltage. So that could change your frequency in the oscillator. Okay. So that's the way it worked. A very simple device. It's a diode. It's just one single tiny, and it's 0402 package or something like that. It was really tiny. So they started failing, and they sent the customer sent back a few, and we took those apart, and found that varactor was dead, that the diode wasn't working, or it was open, and I had those parts sent to an independent failure analysis lab that could do a cross section, do X-ray, do the cross section polishing down, and look at the side view of it. And inside that varactor, where the two wire bonds were in a cavity where the wire was, and the wire bond, or the wire itself, had apparently evaporated inside the encapsulant channel, providing enough molecules of gold to reach the silicon diode, the silicon die, and actually bring a voltage to it. Because a varactor is a voltage device, and very little current runs through it. You're reverse biasing a diode. It was working. I mean, it was working even with the plated, encapsulated where the wire had been. It was plated along the walls with gold enough to touch it. But of course, that was, as soon as it expanded and contracted, a few
times the fire cracked,
and it would fail. So I clearly showed this to the owner, and he of the company. He said, "No, there's no way that Toshiba or whoever it was, or whatever company, they could never send us bad parts like that." And I said, "Well, this came on this came on a tape reel of a million of those things." Yeah. And along somewhere, either somebody ESD or set the test rig wrong or something, or somehow these things had received such a jolt of electricity that they had evaporated the wire, but didn't damage the die. The silicon die was still functional.
Well, it had a fuse in the way. It had this chunk of copper that acted like a fuse. Yeah. Just melted. No, but you sent it back to the vendor. And,
yeah.
I mean, I had one that was even more ridiculous than that. Mine wasn't technical at all. It was a crystal, a can, just an old fashioned crystal used on almost every electronics board for getting a steady beat, so you knew what the timing was, right? And we had one fail, and we suspected that the crystal had cracked. So we said, all right, well, how do we prove that? It's got a metal can, so we can't x-ray through it. So we cut the can off. We got a little Dremel tool and cut the top off. And I told the vendor about that. And he says, well, you're not allowed to take the can off. I was like, what do you do to troubleshoot stuff? Well, we take the can off. All right. Well, that's what I did. And I sent him a picture of it. Right. And it was the leads in the can are like two little diving boards. And, and there's actually a little piece of crystal, a little piece of this glass thing sitting on there. And they're glued on, is probably not the right term for it, but they use a little silver epoxy. And it's done by a machine. And the one we had, imagine that you have a diving board and it's attached to the end of the pool, right?
Right.
And half of the attachment's missing. And so if you dive on it, all the force is being taken up by the one anchor.
Right.
And the way this thing failed is it cracked the die, the crystal, right at where that end of that bead of glue ended, right? So it cracked right at the high point of stress. And they first said, well, that's not possible. And it says, okay, well, here's a picture of it.
Right. Exactly.
Well, and then it says, well, you must have tampered with it.
Right. They'll first blame you.
Yeah. A couple of different ways.
And how you disassemble it, how you
caused damage to it. Right. It was your process that did this. And he said, well, how did you find the damage? And it was in a Halt test, actually. Yeah. We were vibrating this thing and it cracked. And it was a handheld device. So it was going to see drops and kinds of vibrations and shocks. And so he said that was a relevant test. And no, it was excessive force. All right. Well, how do you prove that your system survives, modest shocks, not getting, shot out of a cannon type shocks, but, dropped on the floor? And they said, well, we drop test our capacitors. Really? How do you, or your
device,
whatever. And they says, oh, we do it right off of this XYZ standard. It's 3 feet onto a carpet. Right. And I said, is there a circuit board involved with this? Or no, we just use the individual device and just pop it. Cut the leads off because sometimes that shocks it too much. And drop it 10 times and we test it and it's fine. It's like, are you kidding me?
Right. Come on, people. There's a lot more to that than just the crystal itself, or, the attachments, the assembly, how it all resonates when the assembly's together is very different than it'll resonate
if it's only half attached. So we went and talked to them, and went through their process, and their poor process engineer had been on the job 3 months, and he was learning way more from us than we were from him. About the basics of just basic process control. You can't just turn the machine on and hope it all works. And there were some of those issues. Now, way back when I first started, or early on, when I first really got into my reliability type of work, I was chatting with Dick Moss, who is the HP corporate quality manager. And it sounds an impressive title, but it was him and one other guy. HP didn't have a lot of corporate office type stuff.
Yeah.
But
they were all site.
Yeah, they were all dependent on the product, wherever they were. But he said, I was running into trouble with some vendor, and he said, all right, they have 5 standard answers. And he says, first they'll blame you. Then they'll say, oh, we know about that. It'll never happen again. We fixed it. Well, what was it? Well, we can't tell you.
Right. They can't tell you.
Yeah, they had 5 standard answers. Oh, we shipped 65 million of these last year, and this is the first failure. So, failures do happen, but it's rare.
Famous last words. We've never seen that failure before.
We never seen that before. And then, you call them back the next week. Oh yeah, we got that solved now. You won't see it again.
Right. Yeah.
But they can't tell you what they did.
Yeah. What is it? Five or seven steps of death of denial. First, it's denial, then it's blame,
it's anger.
It's kind of the same thing. It's like there's a pattern, and that's why, of course, you really need to do independent failure analysis on most everything.
Yeah, and that's really the gist of this thing, is that over time, we have chased the lowest price, we being mostly procurement organizations.
Right.
And so instead of making capacitors in the United States, which I don't know if we probably did at one point or another, they're made overseas. And then we wanted lower prices even after that. And so they got rid of their engineering staff and R&D staff and stuff like that. And you and I were chatting before we started. We both have experiences where we know more about their technology than they do, which doesn't seem right at all. But they can make it. They can make about 1 billion of them, but they don't know which elements of their system cause the product to have a latent defect and fail after some period of time, like cracks in a ceramic capacitor.
Right.
They'll pass the end-of-line test. They'll look like a capacitor all day long.
Right.
But then they blow up and don't work anymore.
And this is where I don't think, and to be fair to the vendor, he doesn't know every application, and he doesn't qualify. This guy making the varactors on a tape reel, which were millions or billions at a time, that they're used in everything, that
they're from space to undersea.
You couldn't Toshiba couldn't stop their manufacturing and go in and do a failure analysis on there and find out whatever this partial reel, lot had gotten blown up by over voltage somewhere along the process.
Yeah, it'd take them forever to sort it out. But we've squeezed them so much for price, they don't have the staff that could do it if they wanted to.
0.2 cent part, you buy 10 of them for a penny or something.
Well, years ago, I was talking to my counterpart at IBM, and they said, well, how do you handle warranty and warranty costs and stuff like that with your vendors? And I was like, I haven't really thought about that. It's
first of all, deny that they're responsible for any failures.
No.
And they don't have any warranties.
No, what IBM did is said, we assemble components, and then our value add is our brand and the software we add to it, right?
Right.
And they said, but we buy resistors and capacitors like everybody else. And
sure.
But they also bought power supplies. And I said, hey, they're a problem. And he goes, yeah, it became less of a problem when we signed the vendor contract that included a clause that if their component fails, they owe us the cost of the entire unit that it caused our customer to send back to us. So they were selling, $10,000 workstations or servers. And so a 2-cent component would fail, or a $20 or a power supply would fail. They were charging them for the unit it was in, not just so the power supply guys are happy. We'll send you another power supply, no problem. It's $10. It costs us more for shipping.
Right.
But now when it's a $10,000 charge, it's like, oh, I guess we better fix that. So that's the only place I ever heard it done. And at the time, IBM was the dominant player.
Yeah,
and they did it. And
that's what it requires, is a huge corporation to even make that kind of requirement. That very few companies would do.
Very few can do it. But
very few can do that.
What I've also learned is that very small companies they pay a higher price per unit for their units. So
because they don't have the volume.
No, but they create more profit per unit than the big companies do. The big company might buy 1 million of them, and they make 1 cent each.
Right.
Whereas a small company buys 20 of them, but they make $1 each. And if you keep the small companies happy, they may become a big company, or they might, start 10 other small companies or whatever it is. But the idea is that they are a bigger part of your profit margin than the big guys.
Right.
And so leverage is that as a small company and you have a failure, is work with them to sort it out. Do the failure analysis, get your own analysis done with it, then bring it back to the vendor and say, hey, look, we don't want a replacement for it. We just want it to be more consistent. And we're willing to share with you what we've learned in the failure analysis part and then help you solve it. And I've worked with clients before that we go to the vendor and say, hey, we're good at process control and all this other stuff. We'll help you get your line up to speed, even if it will help our competitors, because we want good parts. And they were very welcoming to that. Whereas the big company just yells at them and says, I want a cheaper price, don't do it again. Most of the time, in my experience. But it's one of those things where you always have something to offer, big or small. You just got to be a bit more creative and nuanced about it. But if you're a small company acting like a big company, you're dead. You're dead in the water.
Right. But if you're a big company like Adele, you have your own
you have your own failure analysis lab.
Yeah, absolutely. SEM and all the things. I had the tools to look at boards, totally independent and components. And
it's amazing. Even after you tell the same vendor, the same technician or same engineer, every quarter for a couple of years, they still don't believe you. Like, you gotta be kidding me.
Well, is any manufacturer, any vendor of components can lose process control sometimes and not know about it. Certainly, the capacitor. Yeah, the Nichicon capacitors were very reliable, and suddenly somebody put in there one that, or somebody tried an electrolytic
solution without the hydrogen.
It was phosphorus, I said, something like that. Yeah, one chemical it's not quite the right formula, and it shortened the life of the capacitor dramatically.
I always loved electrolytic capacitor talk because they'd say it would vent. It's like, what's venting? Well, it blows up.
See that little cross at the top?
That's to direct the explosion.
So it goes up and not sideways.
Yeah, it doesn't do any good because it's in a box. It's going to go everywhere.
Yeah. But for the most part, electrolytic capacitors are still, I have them in that pinball machine is 40 years old, and it's still, they're doing fine. I haven't had a problem with them. So they can last forever.
If you
virtually
regularly use them, if you have a big Canon, an old radio that hasn't been used in 50 years, you're well advised to replace them.
Yeah.
If it's used, the dielectric continues to repair itself. The aluminum oxide will continue to deposit, and then in its use, it loses some and then it redeposits. It's like a light bulb, the old filament light bulbs. But
there's so few systems out there. I illustrate pinball machines that are, because they have a long life. What else do you have that have electrolytic capacitors in it? I mean, this
inverters.
Little radio I talk about that I'm using for my audio output, that it came from my father, and it's probably 1970, maybe 80.
Yeah, no,
and it's got probably capacitors in it.
Oh, I'm sure it does. Yeah,
but they're fine, and I use it all the time. I mean, okay, I use all the time. Yeah, my pinball machine I don't use all the time, but it was.
You don't let it sit for 7 years or 20 years.
No, but it was en route, so it was used. But now it sits quite, days and maybe a week sometimes without me turning it on. So, it depends on a lot of factors on that aluminum electrolytic, and how it's made. Some of them were made in paper. What was it? Paper? I remember wax, and that's where I couldn't subject it to very high temperatures. Back in my storage technology.
Yeah.
Back in the 80s, I was, with storage technology here, and they had wax capacitors. So
no, it's one of the issues is that, and I ran into this long time ago, is HP was in this cycle of just outsourcing all their manufacturing. And one of the last prototyping systems we had was in Singapore. And the director of that was like, this is really a fundamental mistake. We lose the factory. And I can't hire process engineers or, factory engineers that really know the equipment, really know the process. And a big part of my job now is to work with vendors to vet them and help them troubleshoot problems and get them up to speed with our products. But I can't hire engineers just to do the paperwork side of this thing with the expertise to oversee these other groups, because we don't have the toys to play with, is the way he phrased it.
No, you got to get your hands. This is one thing that bothers me about a lot of engineers, that they're not willing to go down and touch the product, open it up, look at it, look at the x-rays, go down to the floor, go
watch
down,
it being made,
watch it being made, even make it yourself, maybe try to put it together yourself. I mean, as a test engineer, I had to take apart servers and computers and pull out motherboards and run them by themselves and things like that. And you start to understand where assembly can go wrong. This is a lot of things you learn. Just go touch the product, go down and touch it.
Well, the bigger issue though, and what we started with is kind of, vendors, are not a good source to help you solve, field failures or process failures or how their product's not failing, is give them, and it comes from this long-standing, we want the lowest price. So they shed that expertise. They shed that capacity to deep dive in failure analysis. It's an important issue, you as the company that bought this component that's causing your system and your customers problems, it's in your interest to solve it. And sending it back to the vendor is a crapshoot. Now, to be fair, there are some vendors that really do care and will try to do the best failure analysis they can, because they differentiate themselves on it. And unfortunately, it's pretty easy to do these days. But the idea is that the vendors are in a tough spot. We want free components with perfect customer service, and we just can't get there from here with that dichotomy.
Right. And you give it to the vendors again, that they can't always
they don't know how you're using it. They don't
exactly.
They don't
exactly.
know.
You could be overstressing it. You could be putting it in a circuit that you've applied
badly designed
high, or you get high transient voltages that suddenly break through the the oxide, and that kind of thing. So give them a break, especially if they're making a small component like a diode or
by the millions.
A capacitor by the millions. I mean, and you're a supply, you're a manufacturer of a assembly or larger
like a
system.
computer or something.
Or you're a small company and making just a handheld gaming, a little, or some not high volume. You don't have the weight and you don't have your own independent lab necessarily, your internal lab like Dell did, to be able to do that at cost, without a big expense. And if you're a small company, that can be a very big expense to go do a failure analysis, go to an independent failure analysis lab.
If it's important to your facility, your product, you don't have a choice.
Right.
You have to spend the money to go do it. That's my point, is that we need to understand the failure mechanisms in order to solve it. It's basic failure analysis, right? And basic good design.
Right.
How does it work? Yes, it costs money. And counting on your supplier to do that is 9 times out of 10 total folly.
Right. But I guess at the same time, this reel of varactors is probably a 1,000 in a reel for auto placement, thing that, a certain group of it was damaged, and, it was a part of that. Maybe the whole reel, we'll never get that back. They were all put into devices. And the fact is that it kind of was transient. It came and went. So that was only that affected maybe 1,000 of those reactors, which maybe 1,000 components.
But it's one of those things that until you understand exactly what's the failure, you don't even know where to look in the process for it. And if it is transient, they're not all failure analysis is simple. There's no doubt. And transient ones are intermittent problems are the toughest.
Or manufacturing costs, right?
Another, but the idea is that if it's of concern to you for your product's reliability and its performance with your customers, in many cases, you need to become as well-versed in how it's manufactured, how it's assembled, the material properties of it. It's not a black box. If it's important to you and your customers and your business, you need to know it. That's the bottom line, in my opinion.
Right. And using a contract manufacturer is fine, but you ought to be able to know how it's built and,
how many are being repaired
and have, have them own, certainly several samples in your own facility that you can use to, evaluate,
replicate customer issues,
customer issues, or not replicate them or whatever. So,
no,
you can't rely on your vendors for that.
No, you got to roll your sleeves up and do it. And yeah, it's not cost cutting, but if you get a $1 million warranty bill because you overlook something, then it becomes real. So if you got stories of this, or know of a good vendor that really does a great job, let's shout out to them. But more often, I suspect you're going to run into, oh yeah, they're not all that helpful. Let us know your questions. What kind of things can you do and not do, and what works for you? And head over to accendoreliability.com/go/SOR. There's a couple of ways to get in touch with us. Kirk and I and the other hosts of the show are available through LinkedIn and our About pages. Hey, your new headset actually, once you figure out how to plug it in, is actually worked a whole episode. So cool.
I expect that if I'm careful and not run over the USB-A plug again, I'll be fine with this one.
Let me give you a little piece of preventive failure advice. Don't let your plugs land on the floor.
Yeah, you're right. I got to be a little more neat and clean. And that's, hey, but the vendor
Why start a new habit now?
Right. Anyway, the vendor could have given me a little cap to put over the end, I don't know.
Nah, that won't work.
All right. All right, Fred. We'll talk to you again soon.
Yeah,
okay.
Take care.
Okay.
Thanks for listening to Speaking of Reliability. We invite you to join the conversation. If you have a question or a topic that you think we should discuss in a future show, please let us know. You can find a comment box below the episode show notes, or just leave a note as part of a review on iTunes.